The next step in using EXAFS Neo for EXAFS analysis requires us to understand what types of files it can analyze, what types of data that can actually be analyzed. So let's go ahead and launch a terminal window. We want to activate our Anaconda environment, so Conda activate EXAFS School, and we changed from base to EXAFS School. We need to move into the working directory for EXAFS Neo Public, and we have to switch to the GUI directory. Then we can activate our GUI with Python 3 EXAFS _ GUI.py, and it launches much faster the second time. I don't know why, but so obviously it's doing something the first time you launch it. Alright, so now we have our working EXAFS analysis tool, EXAFS Neo, and we want to pull in data to analyze. Well, the GUI itself right now can only handle absorption data and chi data, but the file format has to have the right set of header lines, and it has to have the right names for the files. So I'm going to open up a few files that I have here. I like to use BBEdit to edit them. One of the important things, if I look, this is an old file of technetium hexachloride. You can see it has a lot of header lines that give us information that we may or may not necessarily need. Ultimately, it has columns of data: energy, mu, BKG, DER, preline, and postline. The ones that are used by EXAFS Neo are the energy and mu, and it is very sensitive to the names. So if your names are not energy and mu, it won't be able to analyze the data. It requires that due to the plugins with Larch that we're using. So you have to make sure that energy and mu are the column headers eventually. Now, if this were xmu, I could delete the x and then save the file. Often you won't have this number of header data in your data file. So if I here have a uranium oxide EXAFS, it's only got one header line, energy and xmu. To make this work with our program, I have to copy this line because it has to have at least 2 lines of header, and I'm going to change it to energy and mu in the second line. Then I will be able to use this in EXAFS Neo. So then I'll go save as, and I'm just going to save this as UO2 EXAFS fix.xmu. I can also have chi data as well. K, chi of k squared, k of chi, k cubed. Same thing, I have to have 2 header lines in this. And this could be the output after doing something like a self-absorption correction. And we'll talk about self-absorption corrections later in another video. So I like to get rid of the spaces, and we've doubled the lines, and so now I will save this data as Molly Chi K fixed. Line breaks should be Unix line feed. Probably need to save that again here. File save as. No, that was already Unix line feed. Alright. Cancel. So I don't need to do anything with that one. Alright, so now I have 3 data files that should be able to be read in. And so I can come back to the GUI. I have data file. And I need to choose a file. So I believe I saved those in documents. And I can always make it look for all files to find whichever ones that we want. So I'm going to load in the fixed UO2. I can choose an output directory, and we'll go through this again. New folder, EXAFS _test, and we'll save this as UO2 output. You have to have the right FEF files, etc. The important thing though here now to see if it works is to look at our large parameters. We don't know if these are good values yet, but we can come in here to background, make the window a little bit larger so I can see it. And we can go plot background in mu. And there we get to see the data that we loaded in for UO2 and the fit using the large parameters that we currently have. You can also come back here, choose, and that was in documents, and we can pull the Molly K. This one won't have any background and mu data, but there will be K-space data and R-space data. So we can now load in the files as necessary.